Hi everyone, my name is Sebastian Molendijk. In today's video I'm going to present you some playbooks that are going to allow you to enrich your incident in Azure Sentinel. Those playbooks is going to be also available on GitHub, so just look for the link in the description and don't hesitate to implement them in your environment and provide feedback either in the comments or directly in the GitHub repository. Before jumping to the console, let's first have a look on the diagram explaining you how those logic apps interact with each other and how they integrate with other APIs to provide this enrichment. So let's spend some time reviewing the schema to understand how this playbook works. So the first thing that's going to happen is that you will have in Sentinel an incident, and based on this incident, what you're going to do is decide to trigger a specific playbook. This playbook will be, in our case, called Get Alert Enrichment. So from Sentinel, you call Get Alert Entities Enrichment. What Get Alert Entities Enrichment is doing, it's collecting from my incident the different accounts that we have in the incident, and it's passing the value of those accounts to another playbook called User Enrichment. User Enrichment is then going to use this information to call different API endpoints. It's going to call first Azure Active Directory to collect details about the user, things like the UPN, the department, the company, the user address, etc. It's going also to call my Azure AD Identity Protection to understand if the user is at risk. It's also going to call Microsoft Cloud App Security. The reason is that we want to get some details about the user profile from the cloud application used by this specific user. And lastly, we're going to call Microsoft Defender Atp Api to get details about the different computers that are being used by this user. All that information is then going to be aggregated into a JSON file. And this JSON, after being composed, is then sent back to our first playbook, Get Alert Entities Enrichment. And from there, Get Alert Entities Enrichment is going to perform a few things. It's going to send this JSON to a log analytics workspace to be used for future advanced hunting queries. And it's going to also send that information in another way. So it's not going to be a JSON, but it's going to be a text formatted information to our Azure Sentinel incident comments. I will also show you in a future demo that you can use the same text that you're posting here in my playbook in the comments into a ServiceNow incident. And of course, if we look at the JSON that we had here, in that I'm highlighting in yellow, what you can do is send this JSON to anything on premises or other cloud solutions, because user enrichment is actually using an HTTP trigger, which means that you can call it from anything. It could be like a future demo using Postman. So you will see that using Postman, I'm going to call the HTTP endpoint and get the JSON, but it could be any other solution like PowerShell or your maybe very specific source solution that you have on premises. Now that you have a global understanding of what we're going to do, let's move to GitHub to understand all the different components that we have in those playbooks. And then after that, we'll move to another demo. So let's review now the different files that we have for using our playbooks. So first we have the parameters here that we're going to use at deployment. And in this parameter file, you can see that here I have two parameters, one for the MCAS API. So this is an object that will require an API token that you have to generate in Cloud App Security, and your Cloud App Security tenant URL that you also have to provide here. Then we have the service principal that we will use to query the different APIs. And this is something that you have to create in your Azure AD tenant. And we will have to provide here the tenant ID, the client ID or the service principal identifier, and the client secret or your service principal secret information that you will generate in Azure AD. In addition to that, you have the get alert enrichment, which is the main playbook that we have here. So I'm not going to cover all the JSON files here. Of course, we're going to look at the designer here. But basically what this file does is that it's calling the main logic app that's going to obtain the enrichment for the users, and in the future for files, computers, etc., all the type of entities that we'll have. And this specific playbook has a Sentinel trigger, so you can run it from within the Sentinel infrastructure. The next one is the user enrichment template. So this is also a very long template here. And this specific playbook here is going to query different APIs to obtain information on your users. In addition to those two playbooks files, you also have the deploy.ps1 file that I recommend you to use to deploy those templates instead of using the portal. You will see how it is when you can use this parameter file. And in here, you can see that in addition to deploying the two templates by using those two commands, I'm also adding for the deployment a custom name, so you can go back for history to review the deployment and check in that everything went well. So let's move now to PowerShell and see how we can actually use the script that we have on the screen. So what you have to do is just go to the place where you have all the different components. So you have your logic app, you have the different JSON files. You just run the script. And from here, you can see that the deployment is starting, and I'm going to deploy my first template, which is now successful. I'm deploying this in a resource group called SOC. And you have here the name of the logic app. The first one was user enrichment. And you also have here the callback URL that I can use to query directly my logic app. And next, I have my other logic app that I'm going to use for performing my different operation against the different sub playbooks. So let's wait a few seconds just to validate that the deployment works fine. It will take only a few seconds. And here it is. So my two resources have been successfully deployed. Let's move now to my Azure Portal to show you how it looks like. So here is my resource group, which is empty, but after refreshing it, I should see my different resources. And from here, you see the different components that have been deployed with my deployment script. So I have two connections. First one is my Azure Log Analytics data collector, and you will have to come here and go to Edit API Connectivity to provide the workspace ID and the workspace key that you want to use. So I'm going to use this Log Analytics workspace to send the information that I'm going to obtain through my playbooks. The next one is the connection for Azure Sentinel. So same thing here for this connection. You will have to go to Edit API Connection, because here you can see that as the status, this is unauthenticated. If I click Edit API Connection, click on Authorize, you can see that I'm prompted for my credentials and validate everything. Click Save, and my API connection has been successfully edited. Let's go back now to my different logic app, and I will start by looking at the Get Alert Entities Enrichment. So this is the core logic app that's going to call other logic apps to provide me specific information. So if I go here and look at this logic app, you can see that it's related to a Sentinel trigger. So when we have a response to a Sentinel incident, I'm calling here the different steps for my user enrichment. Currently, I only have the user enrichment, but I will add over time things like file information, device information, IP address information, or any other type of information that you would like to add. You could also add something like formatting some messages to send an incident information to ServiceNow. That's something I will show in a future video. But if you look here at the scope, it's pretty simple. I'm just collecting all the accounts that I have in my Sentinel incident. And for each user, I'm going to zoom out a little bit here. You can see that I'm then going to call my user enrichment logic app. So this is the second logic app that we deployed with our script. And what I do here, I'm collecting the output of that logic app that's going to send all the details I want for my users. And you see here that I'm actually splitting the information in a few different compose actions. And the reason I'm doing this is because currently the Sentinel commands only allow you to provide 1,000 characters. So I'm going to create different comments with different pieces of information. I will show you the result a bit later. And the next thing that I'm doing, I'm also going to collect the information, the JSON information collected from my logic app here, and I'm going to send the detail to a log analytics workspace, or it could be the same workspace as the one that you have within Sentinel. So the idea here is to provide this information for future usage. So if you want to hunt or reuse that information for other queries or maybe some custom detection, that's the idea, without having to run again this logic app. Let's have a look now at the call user enrichment logic app, which is where we're going to collect all that information. And for that, I'm going to click here, click on edit. And here you can see that this logic app is waiting for HTTP request. So it means that you can call this through other logic apps, but basically I have an endpoint provided here. So it means that I could use anything to call this logic app and provide in my body a user principal name. So I can call this through my logic app, but I can also call it using PowerShell or using Postman. I will show you how it works by using Postman, or you can even integrate this with another source solution that you would have on premises or anything. Basically, this logic app is working like an API waiting for user principal name, and is going to send back a JSON providing all the details you need for your users. After that, I'm parsing this trigger for future usage, initializing a few variables. So the first one here, user MCAS ID, is a variable that will contain the user information for calling the MCAS API. So we need to format it and generate it in a specific way. I'm going to also create a device array that I'm going to add to my response. I'm also adding a location total activities variable here that I'm going to use when I want to provide all the details on our user habits when accessing cloud applications. Location will be an array containing all the location used by the user. I'm going to send back also all the inbox rules over the user, potential admin roles, and self-service password reset activities. Next, you can see here that I have a few scopes. So those scopes allow me to organize all the different actions per type. So why am I doing this? First, it's much easier to read when you have multiple actions, and you will see that there are a lot of actions within this logic app, but also it allows you to be very modular. So when you're creating your logic app using Visual Studio Code and playing with the JSON when you're editing your logic app, you can easily create copy-paste by taking the full scope instead of searching across the JSON for all the different components that you're going to reuse. So the first thing that I'm doing here in my user scope is that I'm calling Microsoft Graph to get the user details. So I'm just calling the API to obtain details about the user. I'm then validating that my answer is okay and that I actually have a successful answer. I'm then parsing the details of the user. I'm obtaining the user manager information. I'm also collecting the multi-factor authentication and self-service password reset status. So here I'm checking if the user registered for MFA and maybe also for self-service password reset. And we're going also to look at which specific MFA methods have been used, like application, SMS, or mail. And I'm also checking the Azure AD identity protection risk status for my user. If this answer didn't work, I'm just sending back an answer with the body. So usually you will have this error if the user is unknown in your directory. So maybe you have some typos, or the user do not have an Azure AD account, and then I'm just killing my logic app. So that's the first component for getting details about my user. And then I'm going to search for my user devices. So if I look at what we have here, and let's zoom a little bit, I'm then calling, oops, let's unzoom. So I'm calling here the Microsoft Graph device endpoint to obtain a list of own devices for the user. So here I will obtain all the Azure AD join and all the Azure AD register devices of the user. And then for each device, what I'm doing is that I'm selecting only the specific properties that are useful for me. So you might remove some of those if you want to edit this logic app, or maybe add a few others. But basically I'm creating a custom object here with the property that I want to keep. And I'm appending this to my devices array. So that's something that will be reused later. So basically I will have now an array called devices containing all the different devices owned by this user. The next thing that I'm doing after collecting the Azure AD devices information is that I'm calling the Microsoft Defender Atp Api, and I'm performing an advanced hunting query. And in this query, I'm searching back in the last 40 days, so you can change this value if you want to. And I'm looking for this user using the on-premises SAM account name or the user principal name. So Defender can use different usernames. So just to be sure, I'm calling the advanced hunting with both names, and I'm searching for information in the last 2 weeks. And I'm then returning a few specific properties like the device ID, the public IP information of that user. And this piece of information you will see in future videos will be very helpful, because I will use this information to resolve other alerts that will be triggered by a different security solution like Microsoft Cloud App Security or Azure AD Identity Protection. After that, so this is the devices component, I'm checking the group membership of my user. And right here, I'm checking the group membership of a specific subset of groups. So here, this technique requires you to put the maybe sensitive group information, your VIP user, or maybe your, I don't know, specific user that you want to monitor. And this is going to be used when you will check the group membership. So if the user is a member of those groups, you will have the information of your user group membership, and you will know that this user is actually a member of that group. After that, I'm checking if the user has specific admin roles like global admin, security reader, compliance admin, or anything else. So anything that you will find within Azure Active Directory. And for each role, I'm calling again the API to get the role details. So I'm doing this operation because these API calls will return you not the display name of the actual role, but a specific grid. And because we want this to be humanly readable, I have to then enrich the information by associating a specific grid with the right display name, like the global admin or the security admin. I'm then appending the different information obtained from the admin role to an admin role array, and I'm going to return that to your main functions. I'm also looking for, in the user changes scope, for recent password reset activities. So if the user performs self-service password reset activities, I'm going to obtain this information. And again, just like all the other actions, I'm selecting only the properties I'm looking for, and you will have details about potential failures. So you might have also failed self-service password reset activities. It might be an indicator that someone tried to reset your user activities while it was not the actual user. So that's something that you will have also as an information. In the mailbox scope, we we're providing something that that's usually helpful for the security analyst, and those are the inbox rules. So here I'm going to call Microsoft Graph and return all the inbox rules that are present in the user mailbox. So I'm not filtering this to look for specific malicious inbox rules, for example. That's something that I will demonstrate in the future using signals from Cloud App Security. So here I'm collecting everything. And you can see that I'm playing a bit here with the inbox rules just to provide, again, just for human readable information. I'm looking for the folder display name, because by default, when you call graph, you will not have the details about the folder name. You will have a grid. So I wanted this to be humanly readable. So I had to play a bit with some additional activities here to provide the right information. I'm also checking the out of office status and the out of office status message for your user. So those information will be also added to the user profile I'm building. And lastly, I'm going to call the Cloud App Security API. That's why we needed an MCAS API token when we were deploying this logic app. And this is where I'm going to compose first the user MCAS ID. So you can see here in this function that I'm concatenating an ID, the also object ID from the user. I'm also using the Office 365 SaaS ID just to create the first some JSON that I will then format using base64 information. So that's going to be assigned to a variable called user MCAS ID, and that's an information that you will see in the user details. I'm then calling the Cloud App Security API to obtain a list of location for your user. So this information is something that Cloud App Security exposes in the portal. So basically it's telling you if the user is connecting maybe at 80% of the time from the US, 10% from UK, and maybe only 1% from Belgium. And those specific activities might actually be suspicious if you know your user habits. So that's something very valuable for the security analyst when they're reviewing activities performed by the user. I'm then collecting all the activities from these API calls just to know how many activities in total have been performed by the user in the last 30 days. I'm going to reuse this information here in some calculation when I'm composing the location percentage. So basically what I'm doing is that I'm going to divide the number of activities per location and convert this into a percentage. And this percentage will be added to a compose action where you will have a number of activities performed by this user and the location, the country associated to this location, the last time we saw activities in this location for our user, and the percentage of total activities for that location. I'm then adding that information into an array that will be used in the end to provide all the location of the users. The next thing I'm doing with the MCAS API is that I'm getting all the information from the user profile, and the idea here is to obtain the investigation priority, or sometimes called threat score. And this threat score is going to be complemented with the threat score history. I will show you how it looks like in Cloud App Security, but this information contains the date, the score. So if your threat score evolve over time, I'm going to display this information. And you also have the percentile. So what's this percentile information? This percentile information allows you to know if the score is high in your company, because depending on the company, a score of 500 can be pretty low. It's not an issue. While for other companies, 500 is extremely high, and you should definitely spend some time investigating your user activities, because our UB engine detected different strange behavior for that user. So that's something that you will see in a few minutes in my test. After this, I'm composing the JSON. So you can see here that I'm going to reuse all the information I obtained from my previous actions. So there are a lot of things, but you have details like account is enabled, admin roles, MFA methods provided, details about the user location, when the account was created, if the user is Mfa registered, also the out of office status, the inbox rules, details about the user manager, the also on-premises information if the account is synced to Azure AD. It can be useful in some cases to know the distinct name, so you know the organizational unit in the on-premises AD where this user is located. You also have details like the risk detail and the risk level of your user. It's coming from Azure AD Entity Protection, the self-service reset password activities, the Cloud App Security threat score and threat score history. So all that information is then sent back to the caller. So in our case, if we go back to the previous example, you can see that the response here is actually this logic app, the get alert entities. So that's how we're going to use that information. So let's see how it works. So first, let me quickly enable this logic app because I didn't enable it at first, and because I'm going to call it manually for the first demo, I'm going to copy here the URL that I'm going to use. Let's move now to Postman. So in Postman, I have a query that, so it must be a post. I'm going to paste here the URL that we obtained before. So that's the URL of my logic app. And in the body, you have to provide, format it as a JSON, user principal name, UPN of your user, format this as a JSON, not a text, which is the default case usually. And if I click send, I'm calling now my logic app by providing this information here. So what's going to happen is that the different API queries are going to happen in the backend, and my logic app is going to compose a JSON file that will be sent back here to my logic app. As you can see, it was quite fast. And here in the answer, you can see that we have details like the admin role. So my user doesn't have admin role. We can see that this account is registered for MFA using email and mobile phone. We have details about the location of that user. We have details about the Azure AD devices from that user. So we can see that there is a VM here called Megan PC. So probably not suspicious because my user is called Megan Bones. We see that this is a Windows PC. It's an Azure AD joint device. There is another one here, another Azure AD joint device. Here we have a register device, a workplace joint. And this is actually my own computer. So this account was used to connect to some cloud resources. So that's why we have it here. And a bit further, you can see that we have another property called MD ATP devices. And this is where I'm getting the answer from Microsoft Defender Atp Advanced Hunting. And here I have two devices that I can identify, which are Julian EPC. So this is one of my test devices, and the public IP address history for that user is provided here. And we also have a second device. And what's interesting is that this device has two public IP address history, this one and this one. So this is a valuable information when you want to correlate this information with other alert or other activities that you will see in your environment. We also have here the Mfa Register. So it's interesting for you to know that a user is registered for MFA. So usually it's going to be less urgent to solve the issue because that should be protecting this account. And we have here the information coming from MCAS about the location usage. So we can see that this user performed 93 activities from Israel, and the percentage of total activities from Israel is only 12%. If I look a bit further, you can also see that I have another location where this account was heavily used, and this is the US, 63% of the activities, and Belgium, 12% of the activities. Usually you will have less location, but this is a test account that we use in our demo environment, and we are all over the world, so that's why you have so many locations for that specific account. We also have details about the inbox rules in this user mailbox. And you can see here that we have a first rule. This rule is called underscore, so probably something suspicious. It might be interesting to maybe query in a custom detection for short names with only a few characters or specific names. And as a condition, there is also a body or subject contains payment, tax, Visa, credit, bank. And as an action, you can see that it's forwarding those emails to notme@gmail.com. So probably something that you want to look at, because in addition to forwarding the email to this external email address, there is a move to folder action hiding the email in the RSS feed. So this is probably a rule which is created by a malicious actor to hide specific activities or email threads from the legitimate users. You can also see here that our user has the out of office enabled. It's set to true. And here you have the out of office message telling you that, dear mail sender, I'm currently traveling abroad with limited access to my mailbox. We have details about the manager. So it might be useful if you have other playbooks running on top of this one. So it could be sending an email to the user manager and asking maybe for an extra validation. And we have the on-premises details for the user, the Azure AD risk status. So currently the user is at risk, but the risk level is medium. So maybe not, you should not be too concerned about this one. And if we go further, we can see that the MCAS investigation priority or threat score is 321. And in the threat score history, you can see all the past values. So you can see that on the 22nd, this user, so this is actually today, you can see that the user percentile is at 100. So it means that the user threat score is higher than 100% of your environment. So that's the most risky user in your environment. If we go back to yesterday, we can see that the score was only 226, and this was only higher than 87% of your organization, but it's probably super high, so you want to look at this. And if you go back in the past, you can see that full history and validate that, for example, a couple of weeks ago, this score was of 0. So it means that starting on the 16th here, this user started to perform some unusual activities, maybe generating new alerts in Cloud App Security. So you probably want to start investigating about this date to understand what happened with that account. And the last information is, of course, the uprint that you might use for other investigation. I'm using here Postman. You can, of course, use anything you want, other source solution. You can use PowerShell, you can use any program, any script, anything you want. It's just like calling an API by just providing this information. And if case you're asking, yes, this I'm not protecting here for this demo, this API call, but you could use some extra authentication, like using some specific tokens, or maybe restricting from specific location the execution of this logic app. So that's something that we can add on top of it for its security. So before moving to the Sentinel portal, I want to show you in Cloud App Security the details that we're seeing here, like the location. So if I go to Cloud App Security, so the first thing that you will see in the dashboard is that this user, Megan Bowens, is actually the top one user to investigate. So she has a higher score than everybody else. And if I click on my user, you can actually see here a nice graph showing you what you were seeing in my JSON. You will have also all the activities or alerts that increase the score. And you can see here the location of that user. So if you click on location, you can see the same result as what we had in the JSON, with United States being 63% of the activities and Belgium being 13%. So definitely something that's easier to read when you're in the portal, but definitely the JSON is more useful when you want to create some automation and integrate your different solution with with the information that you obtain on that user. So here we are back in the Azure Sentinel incident, and let's have a look at how we can use the playbooks that we now created in our environment to get benefit of the added information. So as you can see here, I have an incident, multiple fail user logon attempt for an entity, so my user name Seb. Let's see the full detail of this incident. And here, what I'm going to do is run the playbook that we imported. So when I go to my playbook, we have the two playbooks that we imported, the get alert entities enrichment being the one we want to use. So let's click on run from here, and this is going to execute the playbook that we had before. So if I open this one in another tab, just to show you the execution, you can see from here that it's still running. So it's going to call the different endpoints as we know by calling the entities enrichment. So from here, you can also see that I created an incident using ServiceNow connector. So that's not part of the GitHub repo, but that's a very easy one to add for yourself. And here you can see that I'm calling my user enrichment logic app. I'm then collecting the details from my user and posting that as different incidents. And I'm composing an updated messages for my ServiceNow incident. If I go back now to my Sentinel incident and I look at the comment after refreshing it, you can see that I created 4 comments. And in those comments, I have details about my user mailbox. So you have information about my user here. Just like we saw with Postman, we have here details about the inbox rules. We have details about the devices used by the user and more general details on the user and the account, like the admin role, the potential risk, and the threat score coming from Cloud App Security. If I go now to ServiceNow to see the same information that we posted here, and same thing, I'm going to refresh this page. You'll see that I created a new incident. And if I look in this incident, you'll see that I have 2 messages. The first one is the one that is telling me that I created my incident at the beginning of my playbook. And then you can see, just like in my Sentinel incident, all the details about my account, my mailbox, the risk level of my user, etc. That's not the end. We also send that information to another place, and this was into a log analytics workspace. So let's execute this command to see what we have in a custom log called users with _CL, so my custom log. And you can see that we just generated here a new record. So if I look at what we have here, you can see that we have again the same information but formatted as a JSON. So we have here location usage, and you can see all the location used by this user with the last activities from that location and the percentage of activities that have been performed from there. The current threat score, the threat score history is also available here. So you can see based on the date, the threat score of your user, the devices of your user from Azure Active Directory. So again, same type of information that you can use when you're querying your logs during your investigation, and details on your mailbox. So all that information is now available as a custom log, and of course you can use it to query the data for all your users, but also follow the trends and maybe create some custom detection from within Azure Sentinel. In future videos, I will show more examples of what you can do with this information that you're saving in log analytics, but that will be for another videos. Thanks a lot for your time, and again, if you have any question, don't hesitate to post a comment here or in the community. Thanks and have a great day.